Been having so much fun with JavaScript, I thought I'd solve one of my favorite problems again. This is one of those toy problems that is good to solve in a lot of environments. If you're not familiar with it, you're just trying to fill a chessboard or some subset of a chessboard with queens so they don't attack each other. And n is just the size of the chessboard, and however big the chessboard is, you have that many queens. It can be a little different from my last few projects. Notice I'm starting with a blank slate here. But this should be a quick and easy one, certainly a fun one. I am going to cheat just a little bit. Let's look at this source code. Here it is. And I'm just going to copy, mostly it's that viewport line. The rest of this I could probably do off the top of my head. Just get the basics out of the way. Sometimes it's good to have this structure up front. It kind of gets me in the mood, gets the blood flowing. Apparently I need it. I have a little trouble typing this morning. Okay, so let's see where we are. Always got to start somewhere, right? Save in Queens. And let's take a look. Not very exciting yet, but got to start somewhere. So we're going to want an input, so you can say what's in. For example, you could have a 3x3 chessboard or a 4x4 chessboard, so n would be 3 or n would be 4. Let's give it a title first. We'll say n equals, good as anything. And of course we'll give this a name. We'll do it two ways because I'm not sure how we're going to grab it. They both work. I don't know if that's going to be a problem. Hope that doesn't conflict with anything, but that's a good enough start. And then maybe a button to say go. Save. And refresh. Not too bad. Let's fill in an answer. Sometimes I find if I write the code by hand the first time, then it'll be easier later. Later we want the program to fill in the answer. But if I do just the first one, that's where I like to start. So of course a div is just a container, a fairly simple container. And this is where we're going to tell the program that That's where the output goes. That's where the result goes. And I'm just going to make some simple rows here. This is just the easiest way to make a row. You could do it so many ways. You could make a table is what I often do, but I don't think so today. Now this first part's going to be wrong. I know it's going to be wrong, but let's do it. It'll show off why I'm doing it. So here's a simple one that's been solved, the 4 queens problem. In fact, let's fill in the 4 here just to be complete. That's way too wide. I think width will do it. I'm not. I have to look that one up. Save. Okay, yeah, it's not width. It's yeah, let's do it. See all the nitty gritty. Input HTML attributes. Why not? Size. Save. Refresh. That's why I like this stuff where it really is easy to iterate over. Sometimes I have to do more work than I can. I have to do a whole lot of work before I can see a result. So you have to have more on faith, I guess. All right, so back to this solution. Get rid of that. We're done. So the first one is space, Q, space, space. Now I know it's going to fail, but let's have fun with this. So at least in the editor, it looks right. This is what I'm going for. This is what I want to see in the output. And I think we know it's going to fail, but let's try it. And refresh. Oops. So what's going on here? Well, the first thing is, wow, it looks like it ignored all of these spaces, even more than I thought. I thought it was only going to do these when they were bunched together. Basically, HTML often will ignore spaces, especially, again, if you have multiple in a row, but apparently even if you just have one next to this tag. But there's a way around it. Means non-breaking space. Looks a lot like a space, but it acts more like a normal character. It doesn't. There's no magic to it. Just like the Q is going to show up. The non-breaking space is going to show up. Okay, well, this should be an improvement. We're still going to have some problems, but refresh. Yeah. So the problem is that so there's some evidence here. Yeah, so you can actually see, just because I was sliding this thing slowly, there is a space there. By selecting it, I could see it appear. Okay, well, the problem is that this is a fixed width font, and this is not. So there's a bunch of ways to fix this. CSS is kind of the preferred thing, but do what I can do off the top of my head. I think that's the right thing. Again, we can look it up. Huh. HTML standard fonts. monospace. Well, there's two possibilities here. One is it didn't get inherited. You know what? I'm going to do it the other way. I'm going to say style, because they gave me half of this. It's font family is the property name, and that's the part that I was going to have to look up. Family. And that should work. Save. Refresh. Yes. Maybe make that a little bit bigger. You know what? I'm just going to blow up this thing. I don't want to spend a whole lot of time on formatting. We've done pretty graphics before. So let's say view, zoom, problem solved. Okay, so what are we going to need here? Well, a lot of things, but let's kind of separate the graphics from the algorithm. So I'm going to say just function solve. Then I'm going to have an input, which is the size of the board. Then I'm going to have another input. I'm going to solve this recursively. Each time I call it, it's the first time it's going to solve part of the problem, but it's going to call itself to solve more of the problem. So I'm going to say, where are we starting from? So initially, we're starting from no moves at all. So initial state. And by default, it's this empty list. This empty list means there haven't been any moves. Simple enough. Actually, if something else planned, I learned this in school. I'm not creating a solution to this off the top of my head. I'm just dumping from my head to JavaScript. All right, so what's going to be the output of this? So one possibility, it's going to say, I can't solve this. I give up. It just doesn't have a solution. So we're going to return false. That wasn't just for your benefit. Comments, as far as I'm concerned, comments are mostly aimed at me. I kind of want to say stuff that's maybe halfway in my head, but by writing it down, it makes it much more clear, and I can see what's going on. Okay, so what else? Otherwise, it returns a list of moves. Simple enough. I should probably show this off a little better because this might not be obvious. It wasn't when someone showed me, but in retrospect, it sure is. So initially, we have an empty board. We could put a queen just anywhere, just saying, let's try this. And if that doesn't work, let's try something different. But I want to organize it. The computer is always going to solve this the same way. So let's come up with something simple. Even if it's brute force, even if I could come up with something smarter, I don't have to. I just want something simple. Well, we know if I put a queen anywhere on this row, the rest of this row will be blocked. Nothing else can go here. Whoops. I thought this would be an easy way to show it off, but don't really use this program a lot. All right, so basically we know that there can never be more than one queen on this row because that's just one of the rules. The queen attacks all the way across. So what if, and we also know there will be at least one queen here because otherwise we'd run out of space. We have 4 queens and 4 rows, there will be 1 queen per row. So what I can say is, I'm going to start from the top and I'm going to say I have nothing, this empty list. Then I'm going to go to the first row here and I'm going to say, where is the queen? In this case, I have it at 0. And how do I represent that? How about the list that just contains move 0? Maybe I'm going to try this and I'm going to realize it doesn't work and I change this to something else. That's okay. We can deal with that later. In fact, we're going to be doing a lot of that. A lot of the way this works is just trial by just try and fail and try again. So of course we've blocked off a whole lot of stuff because this queen is here. So now we have to pick a second one. Again, we're going straight down. So that part we don't have any choice in. This first part we had 4 different things, and I just chose the obvious one first, but I could always come back and try another one. But here, 2 of them are already blocked, so I'm going to pick a different spot. Again, we're thinking about the computer. I'm just going to pick the first one that's available. Why not? And then we can always pick another if that doesn't work. But this one blocks out here and here and here. So I can write, well, this was spot 0. We always start from 0. Spot 1, spot 2. So this one we're trying number 2 for this row. Oh, tell me that just crashed on me. Well, that's real, so I guess we're going to keep it. Sure hope it auto-saved. Okay, so we obviously lost something here, but this was position 0. Yeah, this is actually surprisingly common. You know, there's a reason I didn't start cursing or anything. I'm just used to this. It's, well, you learn to have tools that save automatically a lot. Programming really, I think, has more to do with just tenacity, just the fact that you have to be more stubborn than the computer. Okay, so we blocked off row 0. We have row 0 right. Now we're going down to row 1, and again, I'm going to pick the most obvious one here. Well, the first one. We're just making it as simple as possible. And then we had our list here. So we were starting. In fact, we already have that part of the code. Right here, this is the initial state, is that empty list. Then we go from there, and one of the things we try is a list containing just 0. 0 for the first row. And then we made some progress, so we're going to try. We still have 0 for the first row. We're not going back and changing anything. We're going forward right now and saying that there's this list containing 2 moves. Row 0, column 0, and row 1, column 2. Okay, let's go back to here. We're filling in everything that didn't work. Okay. Well, now we have a problem. Now we get down to row 3, and there aren't any possible moves. We know there has to be something on row 3. There's no point going to row 4. We just know that this is going to fail. So at this point, we return false. What does that mean? Well, there were a lot of things we didn't try. We could go back to this row. Can't quite fit the word false, I guess. Oh well, you know what I mean. Why it wouldn't, doesn't matter. All right, well that is false. So anyway, we can always go back to here and we just record the fact that, well, this one failed, so we're not going to do it anymore. So let's make this one blank. Let's try putting our queen here. So what's going to happen? Well, I'm going to block that out. I should have done a better job cleaning up. And then in this next row, what do we have? Well, this one is still blocked from immediately above. This one's blocked from two different directions, have two different diagonals. This one's open, so maybe this will work. And by the way, this queen, let's not forget, it's also going to block out this last row, which we will get to. But again, this one opened up. We thought this, our last attempt, this one didn't work. So let's put a Q in here. Oh, and by the way, we didn't update this yet. That was my main thing. So now we're trying something different. So the whole idea is the first time we called solve, we gave it this empty list. So solve said, well, one possibility is to make a list that only contains 0. So it's going to call solve again to find the next row. But this will be the input. And then it'll call it a third time, this time with 0, 3, to try to solve the third row. Okay, so this time we actually made a little more progress. We got 1 here. Totally forgot that we start counting from 0. I should know better. And this time we are making progress. Instead of false, we have 0, 3, 1. Well, there's only one problem. This queen here knocked out that spot. So now there are no empty spots on our fourth row, the last row. So again, we have to return false. We just don't have anything else that we can say. So let's take another look at what I did here. I took a look at the first row and I grabbed the first possibility. From there, I split it up into two possibilities. This one and this one. This one immediately failed. Does this sound familiar? This is like the triangles. Here was our first triangle. Split that into two triangles. This one immediately failed, like the too thin test, only now it's no room for a queen test. This one went a little further, so we tried another thing. We added one more possibility. But it failed too. That's as far as we got. So we're now backtracking. And finally, we're going to go up to this first one. All that discussion of breadth first search and depth first search, yeah, that's real. That wasn't just something for drawing triangles. This is how you solve a lot of real problems. And this is depth first search because we are going into detail about each one. Remember, this is the second thing we looked at, was the possibility of a queen here. We're not even going to get to it until we threw out every possibility where the queen was in this first column, excuse me. So depth first search. We could have done it other ways, but this is absolutely, in my mind, the simplest way. All right. So how do we do this? Well, first thing I want to say is what's blocked. Or you know what? Let's say what's available. They're kind of the same, but I think available is going to be a little bit easier to work with. And I have this empty set. It's not a list. List is nice, but instead this is well, I'm going to call it a map. I think it's an object in JavaScript terminology. But the idea is that it's going to be easier to delete stuff from random positions. It's not that you couldn't use a list, this just seems like the appropriate data structure to me. Now I'm going to fill it in. Initially, I'm going to say, well, oh, you know what? Totally forgot the most important part. If size, so this is how big the board is, equals, double equal, single equal sets the value, a double equal compares two values. So if size, the size that we're going to, is the same as the length of the part that we've solved so far, is that going to do it? I think it's a property. I don't think there's parentheses. It'll tell me if that's wrong. But the important thing to see here is that if we try to solve something and we've already filled it all in, then we're done. Remember, we just keep calling this over and over, and at one point it's going to have to say enough. So if it's equal to the initial state, well, guess what? The initial state was the solution. So I'm going to say return initial state. Perfect. Okay, so now what's available? Well, I'm going to need, in the example here, we had 4 things across. It could be 3, it could be anything, it's in. So I'm initially going to grab all of these things here, these cells. I'm just going to draw them out. So for I equals 0, I is less than size, I plus plus. So you just see this so many times. You're just going to say, in this case, it'll be 0, 1, 2, 3, but it can be anything we want, whatever the input is. Then I'm going to store this in available. And I'm actually storing it twice. I'm saying that if someone asks about 3, the answer will be 3. If someone asks about 2, the answer will be 2. If someone asks about -4, the answer is going to be undefined. So that's not going to be useful. It'll be obvious which ones are still available and which ones aren't. Okay, so first we put some in there, but then we have to block out all the ones that have already been used. Simple enough. So we will iterate through this list of the initial state. So this is what someone's already given us. So if we're working on the 4th row, someone will have given us 0, 3, 1 or something like that. If we're working on the 1st row, someone will have given us this empty list. Okay, so for row equals 0, row is less than initial size, row plus plus. Yeah, that looks reasonable. So we're going to iterate over this list. This first case, it won't do anything because there's nothing in the list. In this case, it'll go through all 3 rows. Well, the first thing we know is whatever position this is. So this has a 0 because we were in column 0. Well, we know column 0 is off limits. This had a 3 because we were in column 3. Well, we know column 3 is not available. So that's the simplest part. Let's do that first. Delete available. And then we're going to grab that item. We're going to say initial state. And we're going to grab that item. So so let's say that this is the initial state. Well, initial state sub 0 is 0. Initial state sub 1 is 3. Initial state sub 2 is, excuse me. So basically the first index 0 will be 0, index 1 will give you a 3 in this case, index 2 will give you a 1. And then we're saying if, well, this would have been in the available list. We just added all the numbers, and now we're going to take this one away. No problem. Now we have to deal with the diagonals. That's not especially hard. Do one piece of math in advance just so I don't have to do it twice. So I'm going to say how far off are we? So if we're looking at the fourth row and we were on the top row, that's a difference of 3. Why is that important? Well, because of this diagonal. It doesn't go straight down. It went down by 3 and it went over by 3. The diagonals actually go in both directions. Here, we went down 2 rows and over 2 rows to the left. In fact, it's hard to see on this small example, but they go in both directions. So I just want to know the difference between the rows so I can compute my diagonals. So offset equals, let's see, so initial state.size says what row I'm on. If there were 0 moves already, we're on row 0, or the first row. I think it's length, not size. Again, some editors are better. They'll tell you right in advance if you make a mistake. We'll see it sooner or later, and well, we will come back to it if it's a problem. So we start again with our position. So again, when someone said we started with nothing, well, we knew we were on the first row, row 0. Here we ended the second row with a list of 2, and we called the function again to tell it to work on the third row. So this had a length of 2, and the third row, again, we start from 0. Third row is row 2. Okay, so that minus the row that we're looking at. So we were looking at each of these rows before the current row and comparing that to the current row. And again, offset will just be the difference there. Now, sorry, it's jumping around so much, my trackpad is way too sensitive. All right, so we just did it. I showed you. You take the position of the original queen, and then you add the number of rows down, and then you also subtract the number of rows down. You do both of those. So I looked up the position for that row minus offset. Now, what if one of these is a negative number, or one of them is off the edge of the board, or one of them's already been deleted? Doesn't matter. Delete won't complain. It'll say, yep, that's gone. You wanted it gone? It's gone. So that's why I like this structure, this dictionary, or I just hate calling it an object. That's such an empty term. Okay, so this looks right to me. So now, let's try all these possibilities. Now this is the part, I looked this up before because I never remember the exact syntax in Java. I am going to do a loop over this available variable that we've been messing with. And it's for in or for of. So I'm pretty sure in is the names and of is the values. Yeah, you can look it up to see more, but I just really needed a refresher. Again, we put the thing in here twice. We said 5 equals 5. There's a few reasons I'm not going to get into why I'd prefer reading the value instead of the key. Again, that's what this in of thing was, which one we wanted. Short version, the key gets turned into a string and the value stays a number, exactly like it was. Okay, so for well, we're iterating over the columns of available. So that's going to do exactly what we were looking at here. In this first case, all 4 of these would have been available. So it'll just say 0, 1, 2, 3. This next case, these 2 were already blocked out. So it would just, available would just have 2 and 3. So we'd iterate over those. And that's what we're about to do. Silly question. If I do this corner here and it doesn't work, do I need to try this corner here? It seems like there's a symmetry argument. If there's no solution with the queen in the top left corner, how could there be one in the top right corner? Same thing with this and this. So maybe on the first row we want to add an optimization. I'm not going to do it now. It's just a possibility. It's the best part about these comments. I can write anything I want. I never have to get back to it. Maybe we'll be interested in performance later, and then I can cut out half the work when things fail. I don't even know how to spell that. That was the best thing about the Mac. The spell checker was just everywhere. All right. Again, these comments are for me, so I'll know what that means. All right. So now, again, we're just looping over. Again, we've already picked what row we're trying to work on. Now we're looking at every possible column. And we've already gotten rid of the ones that are illegal. Now, if we find a good answer in here, we're not going to keep looking. We're only going to return the first answer that we find. So this will be a return. It won't keep running the loop. It won't keep running the function. It will be done, just like up here. We just immediately said return initial state when we were done. In fact, basically one's going to call this, and then it'll bubble up through all the others. Everywhere else it'll say if the recursive case returned a good value, we are done. We're going to keep working. So what does that mean? And if not, we're going to keep trying. So what does it mean if we got through all of these? Well, that means that we failed. We've looked at every possibility. So just as promised, there's no more work to look at. You saw that. We were down here. We had this empty list. So we knew there was nothing else to try. And then since this one failed, the previous row and we discussed that before. I'm not going to review that again. All right. So what are we going to do? Well, let's say, well, first thing is we need to modify this list. I've been just typing here. I said 0 became 03, became 031. And if you've been paying attention to this programming series, you know this is real simple. I would just call push normally. There's one problem. I don't want to change the original. I want to make a copy and change it. So if I go back up, the fact that this thing failed doesn't matter. This one should still be 0 because I'm still working with it. I might still try other things. Versus this 031 was just a copy that I kept adding stuff to. So how do you copy an array in JavaScript? Well, you know what? Maybe I should have prepared that one, but let's do it. Converting to strings, popping and pushing. We've seen all this before. Shifting, changing elements, deleting elements. Yeah, some warnings about if you try to use delete in here. But again, there were lots of reasons why we deleted from an object instead of an array. Splicing, merging, slicing. I wonder if I can't be confused there. I know I've seen this before. I might be wrong. I like the way it finished it. So, does not alter the original array, returns a shallow copy. All right. Part of me wants to actually try it the wrong way just to prove to myself it's wrong, like we did with the fonts, but I don't think so. JavaScript clone array. And here it is. Here's a smaller version of the same thing. Okay. Again, you can look this up, but this is one of the most important things. When I'm working here with my example, I kept modifying the board, and then I had to remember. Remember when we did this second row the second time, I had to remember what I was cleaning up. That's not how the program wants to do it. Every time I just make a fresh copy, and I modify that copy as much as I want, and then I can throw it away because I still have the original of what I started from. So, again, these are the things that I know just because I've been there. If not, it might have been an interesting thing to show off as what it would look like if I didn't do that right. All right, so let's say try this equals initial state slice 0. So again, this weird thing really just means clone it. Take the initial state, make my own copy of it that I can modify any way I want. Then try this dot push. So this part is the easy, obvious part. We know the column We're going to try. So again, this is exactly what's here. We copied the empty list, added the 0 to it. Copied the list with just 0 in it, added the 3 to it. Copied the 0, 3, and added the 1 to it. Okay, so now we have a couple of, now what do we do with this? Well, this is the easiest part. I said this is recursive. We've made some progress, and now we're going to call solve again. Size hasn't changed, that's the size of the board, but the initial state has gotten a little bit bigger. Well, that's not quite right. We need to check on the results. So let's say if the result doesn't equal false, I didn't write doesn't equal false, that's just implied. Const result equals solve size, try this. If result, I'll write it all out, does not equal false, it means the exact same thing. Result does not equal false, return result. Otherwise, it's going to hit the bottom of this loop, and it's just going to keep trying, and if nothing else, it'll eventually get to this false. So, we can't quite test it yet, but that is the heart of it. And, well, of course, we don't know how much progress we've really made till we try to test it. How about display result? All right, so this is going to copy the output of solve to our board here. So how hard is that? We have a whole bunch of numbers. So what do these numbers look like? So we have a 0. That means what? Print this in column 0. Easy enough, you just print a Q. What about this? We have a 3 here. That means print a Q in column 3. That means print 3 spaces followed by the Q. Well, that's real simple. These are just loops. This is hopefully going to be trivial. And I'm going to write some HTML code. You should actually look into DHTML if you're dynamic HTML, if you're going to write a lot of programs like this. But for something so simple, yeah, I'm just going to do this the simplest possible way. So I'm going to build up the HTML as a string, and then I'm just going to tell it to display all that at once. And what I want to do is fill in the inside of this div. So I know each row will start with another div. I don't have to worry about this one because I'm only going to fill in the insides. Oh, I never gave it a name. We'll give it a name while we're here. Oh no, there it is. Yeah, it's up at the front. Okay, so let's say for Oh, yeah, it's the same thing. I want the of. If I tried the in, it would just always give me the numbers. It would give me the indexes of the array. So I'm going to write for column of result. So this will be the values in there. This will be the 0, 3, 1. If I had used the other keyword, if I had said in for in, it would just give me the indexes 0, 1, 2, which is kind of useless. I mean, there's a reason for it, but it's not the one I'm looking for. Okay, so now we're looking at every column in here. And the first thing we know, this is why I did it all by hand first, so I can just copy this stuff. Makes my life so much easier. So now I'm going to say as HTML, I'm going to append the word, this tag that says div that starts a new row. Then again, I need to insert some spaces before the item. Down here, I put in spaces afterwards. Now that I think about it, I'm not going to bother. There's no point in that. No one will see it. So now we say for int I equals 0. Always start counting from 0. I is less than column I plus plus. That's just how we do it. And for each one of those, we want to add a space. As HTML plus equals space. Oh, almost made that same mistake. NBSP, non-breaking space. Then I'm going to add the queue, and I'm going to close out the div. There we have it. That is a row, and we can do that for every row in the result. Then all we have to do is put it in place, which is very easy. Again, there's other ways to do it depending on the circumstances. I would totally, I just don't want to look so much stuff up, and this is just the simplest way to do it. So how about document, how do I look stuff up? Get element by ID. All right, am I see? Oh, not sure I like that feature. All right, so we look up output. And then we set a property called inner HTML, I think. Again, if any of this doesn't work, we'll find out soon enough. I'm not purposely adding any more bugs. I think there'll be enough that we can have an interesting example here. All right, good chance that that'll work. So now we need to do the main part from the button. So let's say function on button click. Then we go down to this the button here. I'm going to add a hook. I'm going to add a so there's this thing called onClick, I believe. Can't believe it would be called anything else. And that's just an event handler. Whenever someone clicks on the button, it will call this function in the code. All right, so I guess we need to read the, here, let's bring our example back, our code so far. So we need to read this value and, just thinking about error checking and the like. Let's just start with a simple assumption that it's going to work. You know, if somebody puts brown cow in there instead of 4, well, we'll see what happens. Okay, so, well, we know we need to find the element first. And this element is called in. Hey, I didn't come up with that. It's called the in-queens problem. And I believe it's called the value. So that's the size. And that's all we really need. So we then making a couple of extra variables here, just in case there's a problem, I can see them in the debugger. So then we're going to say const result equals, what's the name of that? Solve. Don't know how I didn't remember that. Size, and again, well, initial state, I don't have to say it the first time. The default value right here is going to work. And then I'll say display result. Again, all of this could have been on one line. I could have said display result of solve of document, this whole thing. You just walk through it. That was my first thought, just because it is so simple. But if there's a problem, I want to see it in the debugger, and it'll just be so much easier if I have this variable here. Well, I'm scared to say it, but this might actually be the end. I mean, we need to test it and see if we're done or not, but there's nothing else that I can really think that we need. So let's say solve 3. Well, that didn't do much. Say solve 5. Solve 0. Okay, well, clearly something's not working. Let's bring up our debugger. And, I don't know, set it back to 4. See, the only reason I didn't say 4 was because we wouldn't know if it did anything or not. Nothing's changed. Let's do the case of 1. 1 is just so trivial. Now, what I don't see here you know what, I didn't hit refresh. I hit save, but I never hit reload. Okay, unexpected identifier. Click on that. I was trying to show both of these at the same time. That's a little hard. Oh, var int I in C++, I would have said int. In this language, I say var. In JavaScript, I certainly don't need both of those. So, save. Refresh. And again, let's try it. Let's say 1. Solve. Available is not iterable. Well, that's a surprise. Did I misspell it? VAL available. So it highlighted everything in green, and it told me that all of those were they're all spelled identically. That was just my first obvious thing. In some programming languages, it would have complained, but in JavaScript, it wouldn't have. So just for fun, I'm going to say, was it in, of? Maybe I should have actually read this a little closer instead of just looking quickly. Now this definitely isn't right, but I just want to see if I get past the error. Well, I take that back. I'm not. It might work. Remember, we had the number as the way I expected it, then the number converted to a string. And JavaScript, just as quickly as it made it into a string, it might turn it right back into a number. So let's say solve. Well, something happened. That's good. There was obviously some sort of a bug, but you can see the pattern. You can almost see what happened. It's like it knows 1 queue per row and 1 queue per column, but it just didn't get the diagonals right. Okay. You know what? Let's just dive right in. Sometimes I'll put statements that go to this console here. I do that a lot, but let's just use the debugger. And this is the part that seems to be failing. So somewhere around here, I'm just going to click and hit solve again. So available, yeah, it's 0 points to 0, 1 points to 1, 2 points to 2, 3 points to 3. I hope I don't see that weird proto thing there. I might have to get rid of that by hand, but okay. So now we're going through all the input rows. So I do see another mistake. I don't think that this is the problem that I was looking for. But this is going to iterate through every row that's possible, not every row that we have. See, we're looking stuff up in initial state. Really, I should only say, show me all the rows in initial state. So back to our diagram here. In this case, I only have 2 rows, so I want it to be 0, then 1 to give me the 2 indexes versus 0, 1, 2, 3, because I know that we just haven't gotten to these last 2 rows. Rows 2 and 3 they just don't exist. No problem, not bad for off the top of my head. So usually I edit these things more. I'm kind of expecting this sort of thing. So if row is less than initial state, come on. All right, again, this isn't going to solve the problem, but let's hit refresh and solve. Okay. So initial state is an array with length 0, and the length is 0. So if we count the first 0 rows, we'll get nothing. Let's just skip over this whole thing, I hope. Step over. Yep. So now available is what we'd expect. It's the 4 regular columns. It's all 4 columns, 0, 1, 2, 3. Okay, so this is the code that I said I didn't really like. We changed it from of to in, and if it's the problem I think it is, it'll be real simple. But we'll see. So step over. So now we are copying, we're cloning that list. It's the empty list. It's not that exciting. But try this as a list that's empty. An initial state is a list that's empty. Step over. Now try this is a list that only contains 0 in it. No surprise. That's how I said we'd start. Just go left to right until you find something that works or you run out. Okay, and again, initial state hasn't changed. It's still 0. Okay, so now we're going to recursively go into solve, so we're going to try the second row. Step into. I should have just said run, continue. So available, again, we rebuilt it, and we're just starting fresh with every time we call solve. So available initially has all 4 columns. Now let's start deleting some things. So step over. Now available only has 1, 2, 3. The 0 went away, and we saw that. Remember the solution that it gave us? It did block out the columns properly. It just didn't do the diagonals. All right, so what is initial state length is 1. So that says we're working on the second row, row number 1. Then row is 0, so offset should be 1. Step over. Okay, so again, we pretty much knew this. The initial state row is 0, and you notice the quotes. It is a string. Remember I told you I didn't know if that was going to be a problem or not, but it might be. You know what? Let's go just a little bit further here. So that's what I expect, -1. And again, that'll be pretty much ignored. It'll be off the edge of the thing. If you try to delete something that doesn't exist, it doesn't care. So step over. Okay, and how about this? Ah, there you go. So it got confused. Offset is a number. This was stored as a string. It tried to add a string and a number, and it didn't know what to do. It converted them both to strings. So remember I said I was a little bit worried, and sure enough, there was a good reason for it. That's one of those weird things that JavaScript does to you that most languages don't. even PHP, that's similar to JavaScript in a lot of ways, you don't use plus to add two strings. You use dot to concatenate two strings and plus to concatenate to add two numbers, and then it never has to guess. It knows what you mean. So, let's see. Let's go back to our code. I see. It was treated as a string somewhere, and then it got passed around in several places as a string. Okay, so what it's going to do now is iterate over every column name. That's what in really means, is everything that's in available. That's the name. Then I'm going to say column equals, and I was trying to do that all in one step. I think it only works for arrays and certain other similar things, just not for objects. But if you went on that page I was just looking at, I'm sure it would show you exactly the trick that I did. It's not even a trick. This is just what you're doing. Saying, tell me all the names in that list we made called available, and then look up the corresponding value, because I know the value didn't get distorted. The value is still a number, not a string. By the way, I am glad that that bug popped up, because it's a real thing and I used to run into it all the time. All right. In fact, I'm going to be optimistic, and I'm just going to say solve. I think that worked. Well, something is wrong, but if we can't solve the one queen problem, that's a bad sign. That should be a trivial thing. All right, I'm just going to set my debugger here. I thought I could just hover, but it's too late. So let's try this again. We'll say solve. And what does the result look like? Oh, well, that's surprising. You would think the one by one queens problem would be easy to solve. You just put a queen one place on the chessboard and there's no conflict. So that's definitely a bug. But there's multiple bugs. We have this false. We know, even though one should have worked, we know others won't. So again, this happens a lot. Just a bunch of bugs at once, and you have to figure out what's going on. So again, number one, we should check for false, because sometimes it will fail. And number two, why did this one queens thing say it failed when it should have succeeded spectacularly? Do I need to show you the solution? There, that's the one queens problem. All right. Well, back to the editor. Display result. If result, so again, if result isn't false, oh, and how do I, that sort of worked. All right. Else, You know what, I'm going to do it the other way. It's the same thing. The order of this if doesn't matter. But if result equals false, I'm just going to put that case first. As HTML equals font color equals red, no solution. Okay. It doesn't much matter in this case, but what I find is often you have a whole series of these. If this one thing is not right, print an error. If this other thing isn't right, print an error. And you have like 10 of those, and then finally you get down to the thing that you're actually looking for. The main thing is last. So the idea is that each error is right next to the condition that caused the error. And then this isn't specific to any one error. It's the body that we were trying to do no matter how many error checks we did. So again, very small. Maybe if we do a larger example, sometimes you'll see what I'm talking about. All right, save. Reload. One queen, solve. I guess I don't really need to trace through this. Oh, else. Save. One more time, reload. One queen, solve, and keep going. No solution. Okay, so at least we print good error messages. Your homework problem. That's one of our favorite things at work. It's one of our favorite error messages. It's just an example of the worst error message ever. You got to have good error messages. Certain things I said, like the formatting, I wasn't that worried about, but I want a good error message. It will save you. If you don't have good error messages, you're going to miss a lot of stuff and you're going to be confused. Okay, so let's not worry about this right now. Let's go back to solve. So this should be just a trivial thing. So let me try it one more time. So again, we're starting with the empty list. There are no moves. List of 0 moves. So we can skip that. Available. Step over. This should fill in. Okay, so 0 points to 0. There it is. There you see the quotes again. It turned that into a string, and it didn't immediately fail. It got passed along a few places. So fortunately, I was expecting it, or else I would have I don't know, I would have been confused for a while. That's the value of experience. You recognize problems. You recognize mistakes you've made before. All right. So now row 0. Again, we're going to skip right over this. There are no rows. All right. So now we're going to go through all the column names. This is maybe where we're getting in trouble. Yeah, I thought that an object was the best way to go. There's other things. There's something called a dictionary that didn't seem like it was necessary, but now maybe was the right answer. Doesn't matter. For now, I'm just going to go with it. All right, so step over. All right, so column name is 0. Again, it is in quotes. It is that string that we're trying to avoid. So column becomes 0, but not in quotes. It's actually a number. Try this. So we duplicated the array, and now we're going to modify it. Okay, so yeah, that looks like a reasonable thing to do. We're trying, we just have that array, and the size is still 1. Ooh, I just noticed that. The size is a string. I don't know if that's going to be a problem, but I'd rather it not be a string. Let's try this. Let's try this the C way, because so much of JavaScript was made to look like C. I'm not going to look it up. I'm just going to guess based on what I know. So I'm just going to say convert to an integer. So this is the part that this is the intermediary between the HTML page and the actual solution. So the fact that we read that as a string, that could have been the word cow. So the main part of the program doesn't need to know that. That's just something that happens once when we read from the user interface. So wish me luck. I'm going to say decent, whoops. All right. JavaScript. Convert string to number. That's the best part of Google. You never feel alone. You know that other people are having the same problems with you. Well, parseInt sounds very promising. Okay. Let's try it. ParseInt. So again, it's going to read that. We're going to put it into base. We're going to assume it came from base 10. And one more time. Let's say reload. And size. Yes, we got rid of the quotes. I don't think that was the bug, but again, you want to clean up all these little details. If there's a million little things wrong that you're ignoring and then something really breaks, all those little things can get in your way. You just have to clean them up as you go. Yes, size is an integer. Step over, step over, step over. Okay, again, there were no things on our input, so there was nothing to block out. Step over. Column name is 0. Step over, we made that into an integer, 0. Again, this is basically doing the same thing. We're just taking that string that was never supposed to be a string and converting it back into an integer. Okay, so step over one more time. And again, our input is, oh no, one more time. So try this is the list containing just the value 0. And that sounds like a winning solution. Okay, so step into. So now we're recursively into solve. Again, we still have the same word size of 1, but we have a list of moves, one move. By the way, testing this simple case with just one Yeah, you want to start with the easy stuff. You don't want to start with an 8x8 board, and you certainly don't want to start with a 100x100 board. And yeah, this was our thing. It says that we're done. That's promising, isn't it? So this should immediately return this array. Step, step. Okay, now we're back to the very first one. This was when we were solving the first row, and it tried to solve the second row, and that immediately returned because there's nothing to say except we're done. So result should not equal false. If result does not equal false, so result is the array. Oh, goodness. All right, so this, among other things, usually this displays output, but you can just give it an expression, and it will tell you the value. And once again, I started with the silly test case because I wanted to make it work. I wanted to make sure. I just hadn't used this tool in a while, and I just wanted to make sure that something good would come out before I type something complicated. So now result is 0. I say not result is false. Well, I never knew that. The list containing 0 by default gets converted to false, where all other lists, I actually tested it once, I just didn't think to test it with a list that contains 0. My goodness. Yeah, JavaScript, it's good for certain things because it lets you do whatever you want, and it tries to guess what you meant. C++, you have to be so much more specific. The problem is sometimes it guesses wrong. So, yeah, that's just totally inconsistent because, oh, yes, all right. So I'm going to say not, because not converts it into a Boolean, but it did it the way I wanted it to. It said that the list with 0 items and the list with, excuse me, yeah, the list with 0 items, the list with only 0, and the list with 1, it saw all of those as true. The exclamation point said not, that turned into false. We'll put in a second not here. Not. Usually the double negative cancels out, but here we're using it for that little bit of magic. Oh my goodness! I'm showing real programming. I'm not showing how I would how I'd write a if this was a real lesson. If I was trying to show you the ideal way, I wouldn't have done it this way. I would have looked up a few more things maybe. All right. So if not result. Oh, so this is going to be the same thing. It's the same problem, even though it's a different bit of code. Found that on accident. Wasn't even looking for that. In fact, probably worth saying something here. I almost considered returning the string fail, just because that wouldn't be mistaken for anything. Now I'm thinking that maybe my first instinct was right. I guess there's something good about being just super paranoid. All right. I was about to describe it, but you can always just look for that. Okay, so one more time. Another famous saying, I just fixed the last bug. Yeah, thought that would have been a saying. Guess not. Okay, so let's get back here and reload. Solve. Okay, well, we're still not there. That's okay. We'll just keep making progress. Solve. Okay, so we have size. Size is the number 1. Step into. Oh, hit step over. Didn't mean to do that, but that's fine. Ah, just as well we got a result. The result is correct. It's the list that contains only the number 0. In case you've forgotten what that means, it's this queue here. There's only one spot, and put a queen there. All right, so now we are going into display results. So step into. Oh, I meant just. I meant if the array is false, so I should have just said not once. Yeah, remember I had this perfect solution for up here. But then I very quickly threw it down here, and I didn't realize it wasn't the exact same problem. It was the opposite problem. But that's a trivial thing to check, trivial thing to fix. Save. Refresh. And let's just continue. Hey, we got our 1 queen. How about that? That is something. Sometimes you have to be happy about these small victories. Let's try 2. No solution. You probably could have guessed that. The only place you could go is a corner, and it blocks out the other 3 corners. What about 2.5? Interesting. What about, yeah, again, we probably could have better error checking, but at least it didn't blow up. That's a good thing. How about 3? I believe 3 has no solution. How about 4? We know the solution to 4. Hey, now it's working. So basically, I think we are done. How about 8? Well, it looks right off the top of my head. I don't know if we need something different here. You know what? I think I am going to change this. It's just a little too hard to read. I could just make a table would be the fastest thing. Well, either way, it doesn't matter. I need to, ouch. But I mean, it looks right off the top of my head. It's just, yeah, I was hoping to avoid this, but let's go ahead and add some colors and do this right. So we're going to need to know the row number. After all that stuff about how I was saying that that I wanted this of, turns out I'm going to have that in, just like we did before. Yeah, in. Okay. So I'm going to get a list of indexes. What are the indexes? 0, 1, 2, 3, 4. Well, guess what? Those are the row numbers. So I'm going to say row in result. And the first thing I'm going to say is const column equals result row. Now I know the row number, which is important because if I want to draw black and white stuff, I just need to know if the row and the column are the same. Okay. Then we'll say so how are we going to do this? Basically, if they're both even, then it's black. So 0, 0 was black. What about here? So row 0, column 1 was white. Column 0, row 1 was white. And then this one, they're both odd. Excuse me, they're both even, because 1 plus 1 will be 2. Can I just add those together? If I just add the two numbers, so this will be 0, 1, 2. Excuse me. So I'm just, here, let me do it over here. So I want to say 0 plus 0, 0. I'm just trying to find the quickest way to do this. So this is the row number plus the column number. And again, I was trying to do this in my head, but once again, it's the computer, sometimes it wants to do what it wants to do. And that's why I sometimes like these tools that are a little more primitive, where they do what you tell them and nothing else. So again, I just added the row number and the column number, and I'm going to say anything that is even is black and anything that's odd is white. Simple enough. So we'll say I almost got even more clever, but I decided not to. Let's just write this out. So row plus column, and that's this number that I was putting here. Then I'm going to say divide by 2 and give me the remainder. Then I'm going to ask, is that 0? And if that's the case, then we'll have a black background, otherwise we'll have a white background. So we'll open this div. And you know what? I use, this is actually where style sheets would help a lot, and I usually misuse them, but I think we can use them right this time. Usually I use embedded styles instead of the style sheets. So that's the only reason why I don't quite remember. So the question is the selector. So yeah, here I'm going to say class equals, and then up here I'm going to set the style. Okay, copy. This is way up in the header, right under, I'm going to put it right under my title. And I'm going to have two of these. I'm going to say black. Yeah, I'm not sure. It probably would have been okay with black. And then what? It's the foreground color and the background color. Set the background color. Set the text color. Oh no, here it is, color. Yeah, that's it. So the foreground color will be white. And same thing here. Let me flip it. Come on. Just keep hitting things. This computer's twitchy. It just doesn't understand that when I press a key hard, I want it. And when I brush against it, I don't want it. Okay. And again, I just want to add this class equals. Oh, I see it. This stays the same. I did that too soon. I knew something wasn't right. We only had the column there. We didn't know which row we were. Excuse me. We only had the row there. We didn't know which column we were doing yet. So now what? Now I need to. You know what? We're going to do this in different places. So I'm going to make a function. This function will wrap some HTML in a color. Okay, so we'll say var result equals. So now we're going to make yet another container, only this one's going to be a span. A span is similar to a div, but it doesn't cause a break in the line. So span class equals, and then we'll say if black background, then that's the class. Else result plus equals white background. Result, so we have span class equals on the right class, close quote, close that tag. Then let's add the inside part. Span. Again, if I had done this by hand like I did for the rest of it, I could just copy and paste now. But I think that's right. So this will just set the color of a cell. I see. We're going to have to change this just slightly. So before we were only doing the part, we were just doing the part to the left of the queue and then nothing to the right. And now we need to do both sides and the queue itself still. So I'm going to say, this is the columns. I'm going to say I equals 0, I is less than. Well, we know the size. The result is a list that has every row in it. Well, we know we're going to have the same number of columns as rows. So I can say, there you go. So now I'm iterating over every column. And then, again, I'm just going to make an extra variable here just to make the code a little more readable, especially if we go into the debugger. All right, so we figured out black. All right, let's do this in the opposite order. So we figured out whether or not there's a black background. Then we want to say, so this is just a different way to write an if statement. We're going to say if all right, so now I'm going to say that we're grabbing the column that the queen is in. I call this I, but I is not a good name. I'm going to say column. So it's just the column that we're looking at currently. And That's just us just iterating over each one at a time. That's how computers work, just the same thing over and over. And we'll say if the current column that we're looking at is the same as the queen column, then we'll print up a Q. Otherwise, we'll do that non-breaking space. I think we're spending more time on some of this formatting than on the original problem, but that's fine. Okay, so we figured out what color we want. We figured out what we want to draw. Now we figured out how to format all of that. And then we add what we have. We put that into the result. And then at the end of the row, so everything in here is for every single cell, but now we're back to the once per row. There's a good chance that this will work. Save, refresh, solve. Again, some editors will show you this so you don't have to go through all the hoops. As soon as you type it, it'll tell you. Refresh, solve. Interesting. Getting close. So some of the formatting worked. Oh, that's surprising. So I'm going to walk through the debugger. Nothing's obvious here. All right, run, solve. So we have row 0. Oh, it's that same silly problem. Those strings and quotes. Goodness, I'm really... I was doing so well with JavaScript until I said, hey, JavaScript's fun. Let me write a program in JavaScript. All right, so row. My goodness. Okay, well, once again, I didn't have any of these problems before. There were problems. I edited out a lot of stuff in the previous examples, and I wrote most of the code when you weren't looking. For row as string in result. Const row equals it's always the silliest stuff that trips you up. Save. That'll probably work. Just fix the last bug. Yep. You know what, I'm going to do one more thing. This is too narrow, so I'm going to set the width of it. All right, so we're going to try this. I believe 1em is just the height of the thing, so if we make the width the same, that should work. Or if it doesn't work, it'll at least be close. Save. Refresh. Inspect. Oh, come on. So it is showing me here the width is 1em. If I say 100em, I mean, there's no sense in doing a half-ass job. Nope, it did not change anything, so it's not. See, this looks reasonable. Yeah, it's not width, it's something else. That's why I usually do these in advance. Let's do this a different way. Too many examples here, too much stuff. See, it's weird, it has this thing, it says it's 100 pixels. So I don't know why it's not drawing it as 100 pixels. CSX box properties. I think that's the picture we were just looking at. Yeah, here's the picture. Width, yeah, all this looks right. All right, there's a different approach. There's something that just says to make everything wider, and I've used it before. Is the only reason why. Oh, I know that I've used this, but all right. Well, then I'm going to try one more thing, just because that's how this stuff works. You just have to keep. Ideally, I would find the actual solution to tell you, but let's try this a different way. Every time we're drawing a cell, let's always just throw in some spaces. Save. And that's just killing me, but with an audience, I'm not going to keep fighting it. Refresh, solve. Yeah, it's still not perfect, but it's fairly close. Is that right? Nothing down there. Nothing this way. Yeah, this 5x5 case looks good to me. 6. I think that's right. 7. 8. Yeah, as far as I can tell, this is a legitimate solution. And I'm going to say we're done. And we're actually done a while ago. It just took me a while to prove it. But again, that's incredibly real and incredibly common. I often spend more time writing test code than actual code to solve the problem. All right, I guess I will post this up on the internet so you can see it yourself and run it or edit it or just look at the source code. Where is view source? I recently moved from a Mac to a PC and everything's been moved. It's the same program, but I just can't find anything. Well, somewhere in here is view source. All right, well, thanks for coding with me. I hope you had as much fun as I did, and now you know how to solve the n-queens problem.